So, welcome back. Half an hour-ish, and then you're free again. So, few more things, few more directories. So we're down to Etsy. Etsy's configuration-related stuff. Point is, when we get there and we ask you to change something in there, you know what it is. That's roughly what it's about right now at this stage, the Etsy directory. Important one is the home directory, and that's where you will be mostly working in. That's where your file system structure lies, right? So we have home directories, and then there are certain subdirectories for different users. For example, home student in this example, home Linux gym, whatever. And within this home directory, the student, being the user in this particular case, can do what it wants, right? So you can create files, delete files, create subdirectories, and so on. But by default, when you log into the system, at least that's how the users are set up, you end up in your home directory. So you can't destroy much outside that one, you know, per default anyway. So it's quite important to know where you are. What else do we have? What else do we need to go into? Mount points. They're relevant if you're mounting external file systems, such as USB sticks. They will be appearing as devices under MNT mount / USB 0 or USB 1 or things like that, right? So you need to keep an eye open if you install, if you plug in your USB stick. Most likely, if you're running the GUI, the Ubuntu GUI, it will appear as an icon on the desktop, I believe, and it's linked back to one of those mount points in there. But if you're working on the console, you should nevertheless be able to find it by just looking to mount directory. Okay, optional installation packages, SBIN system binaries. So they're different from the user binaries. That's the stuff you use every day, ls, cd, and so on. This is system binaries. That's more like for critical operations such as system recovery or system maintenance and so on. Not stuff you commonly interact with. SRV, yeah, you find in some distributions that's where service information lies. I will not go into that. Temp directory is temporary files. The assumption here is if you, for example, download a file temporarily, want to unpack it and do something with this, unpack it there. By definition, more or less, temp can be deleted at any time. So you shouldn't expect anything to be there if it has been there 3 days ago. It's just a temp folder for anyone and anything, really. Please.
Cookies there or something?
Cookies are stored, as far as I understand, in the home directory because they're specific to user. Temp files is more like if you're downloading a package for installation, such as well, in the instructions that we gave you, we asked you to download to your home folder. Slightly irresponsible, but it would have been more appropriately been the temp folder, for example. That's the kind of stuff, large files, ISO files, things like that, right? That you don't want to store in your home directory because they only have very temporary meaning, right? You install something, then you don't care anymore, right? That's what it's for. So the user directory is quite relevant because that's if you install applications, especially if you do it so manually, and you have done so with Go, I think. You untard it, if I got it right, into user local Go something. That's where the user applications actually lie. So if you install something as a user, most likely it ends up somewhere in user local. Yeah. So that's where installation files go generally. Then we have the variable files. That's files that constantly change. Don't consider them static, like the configuration files, for example. They are more or less static once it's set up. But here's stuff like log files. So var/log is a classical location to figure out all your, or to find most of your system log files. Log ls. For example, here, so there's a subdirectory var/log, and you'll find log files related to Aptitude. That's the advanced packaging tool for installation regarding authentication. Also very nice. Nice exercise, if you're running a cloud server, just run a tail-f on the auth.log because you can actually see how many people try to log into your server and fail, hopefully, doing so. And a very important one is and we'll come back to that, is the syslog. Because the syslog is containing all, well, it's the main syslog information. So anything that's done in the system that's logged will enter by default your system log. So if you install software, if you modify software, to some extent interact with the system. What I did just now is just to run tail syslog. It shows me the 10 last entries in the syslog, for example, quite straightforward. If I'm a bit naive and run it like this, Oh, that's actually short. Okay, I'll take that back then. In this case, the syslog is really, really short. But if it's longer, like 500 megabytes or a gigabyte, perhaps even, then it actually takes quite some time to run over it. Yep, and it basically just says what happened in the background and so on. Oftentimes not really related. Most important is to find out, okay, which user is actually running it and which service does what something. So systemd is the service of choice here. That's the runtime manager that runs all the services in your system. Doesn't really matter, but it's important for you if you run software trying to install something or things go sideways, good location to check out. Yeah? Okay. So I know it's a bit yeah, tedious, but we're nearly done. Root is the home directory for the root user, so that's different from the other users, so it's kept separately intentionally, and proc, as I mentioned before, is process files. So those are a few directories just to bear in mind. Of course, this is available in your slide set. It's fairly standardized, and you can look it up anytime you want. See it more as a reference sheet than something you want to learn by heart. We'll not ask those things in the exam, unless you insist, but it's good to know in any case. Coming back to file systems, something you want to know is furthermore symbols. So very practical, absolute and relative paths, because we struggle with this every year. What's the difference? What is an absolute path? What's a relative path? Carl?
The absolute path will always start from the root directory and go just tell you specifically exactly where the file is, whereas the root folder is relative to the working directory where you're currently in the terminal.
That's right, exactly. Did everyone understand that?
I didn't hear it.
Okay, so I'll just amplify it again. So Carl said everything or absolute paths are always specified starting from the root directory. So they're going through the entire folder structure until they reach the file or folder you're interested in, right? So it would be something like, using this example here, it would be /home /gym /calendar /September /3, right? As a file, for example, because the idea is accessing a file here. Relative paths, however, they depend, they're relative to the location you're currently in. So if you're, for example, in the folder, assuming you are logged in as Jim here in this example, and you want to navigate to September, how would you navigate there?
CD calendar /set.
Yeah, exactly, right? So you just say CD and just calendar, no slash in the beginning, just calendar, and then September, and then the file of choice or whatever else, right? So that's the key difference there, that we basically have the leading slash. What's the alternative notation we could use if we want to navigate this way? What's equivalent to just say calendar?
/calendar.
Correct. So there's two more variables you want to know that are really meaningful in the Linux concept with respect to relative paths. So we have slash is root directory. The dot is the current directory. So if I, for example, say, so I'm still in this log directory. If I say ls, it prints me the content of the log directory, whatever that is, doesn't really matter. If I type ls dot, it does the same thing. It says, now explicitly, please print me the content of this directory. Yeah. So what Carl just said was alternative to actually alternative to navigating by saying, for example, cd is there any subfolder, cd apt as a subfolder, and so on. You can also say cd dot / apt. That's also relative path, but it's very explicit in the sense that it says start from this directory. Yeah. But it's important. It's semantically completely different whether you start with a dot in the beginning or whether you start with a slash in the beginning. Slash always means forget anything about my location, go to the top of the system hierarchy, and then navigate from there. Right? It's both have their advantages. What are the advantages of absolute paths? Come back to you, please.
They will always be accurate.
Yes.
They are independent of where you are.
Yeah. So conversely, what would be the advantage of a relative path?
They're shorter.
Yeah, exactly. Right. So it's convenience over accuracy generally. Right. So please. Yes.
Any question?
Yeah.
It's more than brief. What was the benefit of using this with the graphical interface?
Again, what's the advantage of?
What was the benefit of using this console mod instead of using the graphical interface?
Yes. Yes. Okay. Yeah. we come back to that. But it's spot on. Remind me if I forget to talk about it. It's very important. It's very important. That's a good point. Piggybacking on your point. Relative paths are shorter. Well, sometimes depends, right? So if you, for example, have a slightly different file system layout, right, but you know that installations will happen in user/local or something like this, then the relative path may be more helpful if the global layout is slightly different over distributions, right? It could be that sometimes, for whatever weird reasons, the relative path could be purposeful there as well. But generally, I agree with you. One is shorter than the other, but you need to know the difference. A significant difference to say slash something as opposed to just a folder name of choice. If you use the double dot, it actually points to the parent directory. So I just ran before ls dot. Please show me the content of the current directory. If you run ls dot dot period, I don't know how you call it, it shows you the content of the parent directory. Right? So it's also one way of navigating. So if you're lost as a user and you want to get back to your home directory, you have another way of dealing with this. And that is, you can say cd, for example, tilde. The wave thing. I don't know. Right? How do you call that in Norse? Tilde? No? Tilde? It's the same then. Okay, cool. Yeah, so you run that thing, and back you are in your home directory, right? So wherever that was, how do you figure out where your home directory is if you're in there? What was the command? Not Carl, because Carl knows that. Someone who shouldn't know that. Yeah? PWD, right? So he would have to say the same, right? Ah, good. That's right. So PWD, right? So it tells you which directory are you in. So you shouldn't be able to get lost. But if you have noticed, in your prompt, actually things change a bit, right? There's user at Ubuntu, and then there is colon and something else. Remember that this colon something else is the path you're currently in. You noticed 2 lines up, or right, 4 lines up, you see something like bar.log. That was the location the user was in, me as a user, was in at that point in time. Now, having changed to the home directory, you see tilde there. And that's, again, a symbol for home directory. It doesn't explicitly write home/user. It actually just writes tilde, so you know, cool, I'm in my home directory. Yeah? So those are a few points to be made there. So it's incredibly important to differentiate between absolute and relative path, because, rule of thumb is quite straightforward. Absolute paths always start at the beginning of the hierarchy. Relative paths are always relative to where you are, and they generally just start with the next lower folder, or, for example, the dot notation, so dot slash lower folder, or dot dot slash, that means parent folder, and then navigate, for example, to the Jane folder from there. So if you're in a Jim folder and you say dot dot slash home slash Jane, you end up here. Meaning go one level up and then go to the Jane folder. And so that's the idea. Please, there was a question.
If you want to just go to your home folder, you can, instead of doing cd tilde, you can just type cd and you'll go to your home folder.
Right, okay, that's cool. Thank you. Does it work?
Yeah.
Cool, thank you. I didn't know that. So, yep, good. Okay, good. Good. Few file system commands. So what do we lock you in later? We come back to the remote direction. So few commands. I'm throwing commands at you. You can try them out when you can at your time. But just telling you how to do some stuff in Linux if you are used to it in Windows from the console. We can again come back why. But if you want to, for example, create files, you can use the command touch. You heard about it. What does touch do? It has 2 functions.
Creates a file if it doesn't exist, and it updates the last modified timestamp.
Cool, right? It updates the access timestamp if it exists already. So touch the file literally. There's also a way of redirecting. So earlier we mentioned that we can create the file implicitly by, for example, let's go into Etsy. Cats, and redirect it into test. For example, what I did here, right? I went into the Etsy directory and printed or redirected the output from hostname into a file in my home directory. Redirection, that's this greater than symbol, right? and then tilde home directory test file. So if I look there now, I should be able to see a a filled test file that basically just contains the whole name, host name, no magic really. But that's what you can do. So implicitly you can create files as well. If you want to append to files, how do you do that? So you don't want to overwrite the file, but append to it? That's right. Exactly, right? You do 2 greater than, it will just append. So if I run the same thing again, and just say append, that's right. And there's cat the output, we'll see suddenly the output is appended. So it's very nice, a cheap way of writing log files. You just append, as opposed to overwriting it. Quite useful for your own debugging purposes, or sort of.
Hostname is what is hostname?
Hostname is as everything is managed in files in Linux conveniently. The hostname is the literal name of the host, and it's managed in the file. It's etc/hostname. Your computer has a unique name usually, right? So you give it, oftentimes provided by if you have Windows, for example, it's often auto-populated based on some sort of unique identifier of your system, but sometimes you have a chance also to enter your name and give it, for example, your name PC or something like this. The same thing here. By default, the hostname is Ubuntu. That's it, right? I'm just using a file that is commonly accessible, so you can easily replicate it if you want to. Good. Other commands, viewing, we talked about cat, head, tail, less, and cut. Those are all means of actually navigating in file. Less is quite nice because you can navigate through files. Moving and renaming files, important thing is a bit of a confusing concept because it's the same in Linux. So both concepts are the same, removing and renaming. In Windows it's different. What are the 2 different commands in Windows for moving and renaming? Yeah? No? Okay, then forget about it forever because you don't need the Windows world. So it's actually MV and REN, I believe, rename. But again, fundamentally the same concept, right? Moving a file, renaming it is actually fundamentally the same thing. You're changing the file. In Linux, there's one command for it, move MV, right? So just bear it in mind. If you want to copy something, it's CP. Appending, as I mentioned before, and an important command, which you don't want to use too often, is RM, remove, right? That's deletion. It's not like DEL, like in Windows, for example, it's RM, to bear that in mind. If you want to delete, or if you want to apply things to directories, so those are the examples for files. If you want to apply to directories, the commands may be slightly different. For example, if you want to create a directory, it's mkdir. What's the Windows command for that? If anyone recalls? Sorry? That's for looking at the directory, but for creating it. How do you create one? MD, that's right. MD, that's correct. So this is one of, at least that's my claim so far. I think that's one of the very few commands where Linux actually has longer commands than Windows. So MD was mkdir. But in all other cases, you'll find that the Linux commands are always shorter than Windows commands. So ls is for listing directories, viewing, moving again, copying, and rm-r. And this R stands for recursive. It basically means delete this directory and everything that's in there, including subdirectories, including files. If you apply rm on directory, it would say, I can't do much here. You know, there's stuff in there. What should I do? You need to be explicit if you're talking about directories. If you talk about individual files, rm works, please.
If you're going to copy a directory with files, don't you need to have a -r as well?
That's right, yes, yeah. I mean, of course, for all of those, there's heaps of options you want to check out. It's just, I'm highlighting the common cases, common pitfalls. This is by no means exhausted. But use the cp-help, for example, to figure out the combination. You're right, you need to be clear that you want to copy the content, yes. Okay, do you have time for permissions? Don't think I have time for links here. Okay, so a bit more painful. So a few important files I just want to highlight that you probably need to get in touch with. We're I put the slide set in there. You can browse through. There's a few more information in there, but I think we're not getting through it otherwise. So there is a few important files that are common to all Unix systems, and one of them is etc passwd. This file contains all user information on the local system. Kind of a bit weird one. It originally contains the passwords for all the local users. But historically, but this idea has been abandoned. The passwords are now kept separately, but the file name hasn't changed. It's still called Passwd. Etsy Passwd is for showing you all users with all their information, group affiliation, and things like this. If you want to see all groups that are created and existing in a system, it's Etsy, looking at the file Etsy group. And just for the sake of it, to underscore the fact that it's all files, run cat passwd. Hang on, what did I do? I said cd, which I shouldn't have. Right. I said now cat /Etsy /passwd. Prints me all the users. Heaps of system users in there. You know, you will never deal with this. For example, data, that's for web servers. System time sync for time synchronization services. So those services also have usernames attached to it with certain privileges or not. And in many cases, you find the last bit. So the syntax of the user entry, the bottom ones are more interesting there. It says, for example, test :x, then it's 105, 107, and various empty columns, then home test and bin bash. The important thing is there, I probably need to bring up a magnifier so you guys can actually see what's happening. In the other cases where I'm referring to those examples, it doesn't really matter, but here I want you guys to be somewhat following. So here's this test entry there. You have test :x, and then you have a number here, and then some empty columns separated by column by commas, and then home test and bin bash. What it means is, first one is the username, the second one is the password, historically kept in that file, sort of hashed, but not meaningfully, so it has been removed for ages already. After that is the user ID, the unique identifier for a user, because every user has that. And following this one, the unique group identifier. Every user is member of a so-called primary group, and that's the identifier for that group as well. But those are not as relevant right now. They're more for like debugging purposes, I would think. But rather more important is, here is indicated where the home directory lies for a given user, home test. And this is the shell that the user uses by default. Recall that we can have multiple shells in the system, and bash being the default one. You see the association here. But it's quite helpful because you can easily identify system services. Looking, for example, at SSHD, right? So the SSH daemon. It's a regular user, looks quite good, has a unique identifier and so on. It also has a home directory it runs in. It's in var run SSHD. So that's already a good indicator. Hang on, that's not a regular user. But even better, this guy can't log in. So every time it would log in or attempt to, it would be redirected into user bin sbin no login. And it basically rejects any login by that user. The idea is that no one can, use keyboard to actually try to log in as a system service. That's also one way of differentiating. Point is, everything is in this file, any sort of system user. So it's very, very powerful and very comprehensive as well. So, but it's also good for you to know if you ever need to deal with this kind of challenge. So let's get rid of this. There it is, my beloved magnifier. All right. Similarly, Etsy group. There you go. It just lists all the groups and unique identifiers. There are various groups. Each user that's newly created gets an own group, so-called private group. The idea is there. Sometimes you want to constrain access to directories to only one user. Well, we actually see later that. And you also need to indicate which group has access to a given resource. And if you only want to ensure that this particular user, but no other user, has access to a given folder, you can associate that user's private group with the group privilege associated with the permission. I'll get to that in a second. But it will hopefully make sense in a bit. Okay, so. As I mentioned before, logs are generally var logs. Syslog is a good way to bear in mind. Having a look at it sometimes makes sense. One word on creating users. There are two ways. There's one scripting mode where you put all the parameters for creating a given user in one line. So that would be user add -d, that's the home directory, -m, actually create this home directory, -s, what's the shell, bin bash, and then the username, asks you for a password, and then the user is set up. And then there's the interactive mode that I used before. That's add user. That's actually asking you all different, like a wizard asking you questions. Why do we have two different ways of creating users? Why do we have two different ways of creating users? Good question. Or not, I don't know. Is that sensible or is that just stupid design?
I think it's better designed that you have more options.
Okay, why is that helpful?
Because different people have different opinions and different ways to do things. So therefore there should be not only one option to do things, but
Cool.
multiple.
Yep, you're going in the right direction. That's about there, yeah.
You can a lot easier automate it with the first one.
Exactly. So the first one is for scripting, right? So the idea is that you have one script, one liner for creating a user, done. Here, again, you have a wizard you need to interact with. You can't script that, right? You have timing issues, you have response issues, and so on. So this is more for the interactive mode when you create a user. It's quick because he asks you all the question he needs to know, right? This one here is tedious because you need to get it right. Getting that one wrong is really annoying, right? Because you need to fix it again. Where was the entry? I forgot the slash here or there, or I didn't create the directory because I forgot the -m option. But for scripting, that's super nice. You just substitute with variables and off you go, please.
Why would you create users? Why would you script?
Yeah. For example, we need to bear in mind this is an operating system and it's meant for server-side use. And again, it's a networked system, so we usually have more than one user. And having hundreds or thousands of systems makes it very useful. In fact, when we later will be working with a cloud setup that we have OpenStack, all of you should have an account, right? Hopefully, right? So to be able to log in and to actually work with this. How those guys set up the accounts? Well, they're not clicking through wizards 100 times, right, or 80 times. They're actually just scripting. Yep.
If you're going to do one thing 2 times, you make a script.
Yeah. I mean, that's a sysadmin kind of thing. There's 2 dimensions. One of them, frequency and complexity, right? So if something is very hard and you do it rarely, then don't script it. But if you do it, even if you do it frequently, don't script it. If something is reasonably easy, like creating a user, you're doing it frequently, script it. That's kind of the rule of thumb there, but you're right. So if you do it repeatedly, definitely. Okay, I don't want to get hung up too much on this because we don't want to drift too much in the drift area, but it's still important for everyone to understand the operating system you're using. Also as a developer. Okay, right, so there was the nasty question about how can I log in as a super user? And that's the question, that's the slide I usually don't want to show anyone. Bad luck, it did. Yeah, so you can do it, right? If you want to be a super user, you can just say sudo su, and it should actually give you a super user prompt. And how do we identify the super user prompt? Anyone? Yeah?
There will be a hashtag.
That's correct. Right? So here's the example. Not sure if you can see it. Hang on, I'll bring up my magic magnifier again. So you see here now that there's a hash at the very end, right? So we have now root at Ubuntu /etc as the folder name, and then the hash. I can do everything now through deleting the entire system. So very dangerous. If you want to get out of this spec, easy. You just press type exit. I'm stuck with my mouse. Sad. There you go. It's very sensitive. You can just type exit and you are back in user land, right? So the point is you can actually nest the logins as well. You can log into one user, then log from there into a different user, and potentially from there log into a third user, from there into a fourth user. And every time you press exit, you get actually one level up again. Very interesting, right? So you can nest your logins as well. So that's one of the features that you allow you to. So you're not only allowed to, or potentially log in as a super user, you can also log in as another user, assuming you know the password, of course, right? So then you can act as a different user for a given time frame and exit out again, right? For example, you have user A, user B, and you want to, as user A, change something for user B just very briefly and go back to your own session. You can just log in as user B, change whatever you want to do, and then exit again, and you're back in your own session. So it's really a quite neat concept and quite sensible as well. I'm not talking about primary groups right now. That is pushing it too far. But environmental variables. One of the other concepts is, and you dealt with this, is that we have environmental variables in Linux. How do you figure those out? Well, in Windows we have them as well. They usually called the class paths, or paths, right? In Windows, how do you call them there?
Environment variables as well, I think.
Simply environment variables, yes. So they indicate things like what's your shell, what's your home directory, and it's specific to the user, to the context. They can also be system-centric. So for example, it also, for example, a variable log name would indicate the log prefix that I'm dealing with. If I don't want to really bother in a script, for example, what shell user runs, I can just use the environment variable $shell to identify the shell the user is actually using. So a lot of those things are managed as well. Why is this important for you? Well, the important thing for you is the path variable. When you set up your Go initially, you were asked to do something to .bash rc. So you probably can bring that up, or if you look at it again after this session, you'll see that there was a request to change your path directory or append your path here. And the idea is about the path variable is that everything that's any location that's listed there is treated as a first order location. That means if you, for example, have Go installed in /user/local/go, or somewhere down there, it would mean every time you want to run Go, you would need to navigate to that folder, right, to run it. Because you can only run stuff in your current folder. Well, your way out of it is to basically add it to the path file, then you can run it from everywhere. It becomes globally accessible. Yeah. That's the key idea behind the path variable there. So because when you succeed, all of you should be able to just run go-version, I believe, or Go version, to identify the version of Go you have installed in your system. So, and that's possible because you're extending the path variable that comes along with this. Okay. So I think I'm not able to do the permissions. That's really sad. Next session then. Well, how do you access variables? So I said already, if you type env, you see all environmental variables that apply to your current context, right? If you want to see specific ones, you access them by, well, generally by saying echo, because it means print stuff out, and then $, and then a variable name of choice. So if I say $path, it prints me out, hang on, there's a lot of little directories. It basically all means any file sitting in any of those directories there, and I'm not reading to you, it's no point, they are all immediately accessible via console, right? You can, for example, use ls in any location on the file system. The reason is that the bin folder is part of the, here they go, the bin folder is part of the path environmental variable, right? So something you want to bear in mind. Why don't we make everything then? Why don't we just put every folder into the path variable? If that's so convenient, because we can access everything from everywhere.
Because it has to go through all those paths if it wants to find a string. And something has to search through everything.
That's a good point, yep. It's another argument you could think about.
There are some commands that should only be mine, not everybody else.
Yeah, you may want to control commands that only for a sysadmin, for example, should only be used by or for scripts, right? Then you're absolutely right. Yeah. Another point, perhaps.
How many files on your computer do you think is just called a.out? How many files called main.cpp do you think there's on your system?
Is there more than one?
Probably more than one.
No. What's the problem then? You know what's the problem then? I don't care. I have multiple.
Well, if you want to start a specific one,
how
do you get your specific one if all of them are available?
Good point, right? So that's the thing, right? You're dealing with because you lose control about the order in which it actually executed. Well, there's precedence implied, but you wouldn't be able to keep track anymore which main.cpp you're actually opening, working on, or which binary you're executing. So it's controlled in the sense that you want to keep it unambiguous, because debugging that one, that is super tedious, right? If you have multiple ls, well, assuming you're writing your own ls executable, the listing directory, and you don't know which one is currently run, good luck debugging this. So don't just put everything in the path directory, but things that matter. For example, your Go binary, because you will only have one on your system anyway, the way we installed it. And this way you're very specific about, I want this one, right? So the user local bin Go or whatever else. That should be used. Yeah, so that's the idea there basically. So I think, good. In Ubuntu, path variables or environmental variables are generally managed in the home directory in .bashrc. If a file begins with a dot, as opposed to the variable dot for directory navigation, it means the hidden file, just as a context. But it basically means here in this file, you can specify environmental variables. How do you do it? Well, this is an example. Declare a new path variable, so path equals old path variable. So that's an accessor, you're using the dollar symbol and then path, colon, a separator, and then the new folder you want to append to it. So for association, you don't use the dollar symbol on the left side, you only use it for referencing on the right side in this particular case. Yeah? And the separator is a colon. That's different from Windows. Windows has semicolon as separator for path. Right? So it's sometimes tedious. If you run something that's compiled for Windows, but it actually should run, for example, from Java, should run in both worlds, it may just be the path variable that's off by specification, but the rest is probably fine. Okay, I leave it at this. There was a lot of pain here. It's always like that, getting all this. Future years will have it easier because now there's a first year Linux course for you guys. Bad luck, it's not, so we need to do it. And then we come back next time about, I think I need to push, or I'm not sure how we do it yet, if we share the session or something with Mariusz, but we still need to talk about the motivation as to why we're using consoles, and we need to talk about permissions. Those are two things that I think are very, very important to discuss. Okay, homework for you, get your Go running, get some system running. If you have trouble getting your dual boot running, install VirtualBox so you have something to fall back to. For the first few weeks, that's fine either way, until you figure out your final pathway. But I would recommend you get something Linuxy going, try some commands, be comfortable, logging in, logging out, perhaps creating a user, deleting files, I don't know, do something. Yep.
When you move a file in Linux, you do command, does it also transfer the user rights?
No, we get to that. That's a good point. So permissions we need to cover next time. Unfortunately, we're running out of time here. But you're right. Permissions are a big beast on its own right? What do you think? Or can I do permissions in 2 minutes?
No, but I think like the settings of the systems, like where you actually find it, like that whole like binary thing that requires the whole slide to like visualize it. Maybe I mentioned it really.
Yeah, I need to have a bit of a talk.
I think I'm
Yeah, Ben, come to you.
or do you live now?